For our Using Numeric Patterns and Relationships unit, we have 3 TEKs. The first one we're going to look at is 3.4i, which is where students are asked to determine if the number is even or odd using divisibility rules. Now, the only divisibility rule they need to know to determine if a number is even or odd is how to know if a number can be divided up into 2 equal groups. So in 2nd grade, students learned what even and odd means by making pairs. So they might have been asked if a number was even or odd. Let's say they were asked about the number 11. They would have made pairs, 6, 7, 8, 9, 10, 11. And they would have made 11 of something or used 11 counters and then said, these 2 make a pair, these 2, these 2, these 2, these 2. And this one is an odd man out, so I know it's odd because there's no partner. That's how we learned this in 2nd grade. They did not spend time talking about the ones place, and if the ones place is even or odd, then the whole number is even or odd. That's your TEK. That's not their TEK. So don't go say the 2nd grade didn't teach them what they were supposed to because they don't know about the ones place. Their TEK says they find even or odd by looking for pairs of objects. And in 2nd grade, they only go up to 40. So that's all 2nd grade. They only go up to 40, and they look for partners or pairs. 3rd grade is about divisibility rules and looking at that ones place and noticing a pattern. That's why it's part of our patterns unit. Here's what I don't want you to do. Boys and girls, everybody write this down. If the ones place is an even number, it's even. If the ones place is an odd number, it's odd. I don't want you to tell them. I want the students to figure out the pattern, because when I discover something by working with it, then I make sense of it better myself. So I can go back and review what happened in 2nd grade, and we can look at some 2nd grade problems and say, let's make some pairs, let's talk about this, and let's make some notes. Maybe we make a T-chart, even, odd, so that we can say, okay, when we make pairs, we're going to write the even numbers down over here and the odd numbers down over here. And then we're going to look for a pattern. What do we notice about all the numbers that are in the even column? What do we notice about all the numbers that are in the odd column? Look at the ones place and tell me what you see. Do you notice anything that's a pattern that might be happening? And then we can apply that to larger numbers, where students have been tested in 3rd grade before with 3-digit numbers, because their requirement is to look for the pattern. So we had a question a couple of years ago, which number is odd, and the answer choices were 3-digit numbers. So they were 514, 350, 168, and 205. And so students did have to look at the last place, or the ones place, to determine if the number was even or odd, and they used the divisibility rule of, is it divisible by 2? So that's how you're going to connect to what they learned in 2nd grade and then what they have to do with it in 3rd grade. So we're going to allow kids to discover the pattern and then apply it with larger numbers than they would have had to in 2nd grade. I want to look at a star question with you for this TEK, because this one tends to throw kids off. We can look at this and say 34, once we've discovered the rule, we know it's even because the ones place has an even number. But then I have to know why. So I know it can't be these that are odd, but I have to know, oh, there's 2 answer choices that are even. I see this kind of question becoming an inline choice or a text entry where students are able to provide the explanation or choose an explanation from a drop-down box. Because really, when there's only 2 answer choices, once I know it's even, I don't even have to care what F or H says. I know it can't be it because it's not an odd number. Now I do have to know why it's even, because it can be evenly divided by 2. It has nothing to do with the tens place. but I see this turning into an inline choice or some other kind of an interactive question rather than a multiple choice where there's just too easy to eliminate some answer choices. So I expect to see that coming, which means we need to make sure we're not just putting multiple choice in front of our kids, but we're having them justify the why. Why is it even? Why is it odd? How do you know? So we're having them make sense of that. Okay, 3-5D is our next TEK in this unit, and this ties back to our multiplication and division units. We've looked at this before already. So this is determining an unknown whole number in multiplication or division equations relating the three whole numbers, so fact families, when the unknown is either the missing factor or product, which means I could be asked something like this. What makes this equation true? And when I understand a fact family, then I know that when I divide something by 11, it gives me 9. I could divide it by 9 and it gives me 11, or I could multiply 9 times 11 and get the blank, or using the associative property 11 times 9 equals blank. So the way students solve this, of course, is by multiplication. This has been tested a lot. It is a supporting standard, but it's one of those that's been tested a good bit where we don't always see our supporting standards tested very heavily in third grade. This is one that has been pretty consistent. So we need kids to make that connection between multiplication and division, and that's these relationships we're talking about. And we're talking about fact families for this particular one. And then lastly in this unit, this is where we will represent real-world relationships using number pairs in a table and verbal descriptions. So that can be addition, subtraction, multiplication, or division. And so we want to expose kids to lots of different types of questions. So I have two different ones to talk to you about. The first one, the kids are given a word problem and asked to find the table. The second one, the kids are given the table and asked to find the relationship. So let's look at this one first. Each day a bakery makes cookies and muffins. The number of cookies the bakery makes is always 12 more than the number of muffins. Right there, kids get confused about what I'm supposed to be adding 12 to. So I want them to write it out. Cookies is 12 more than muffins. So what are we talking about here? Technical difficulties. Give me just a second. Okay, I seem to be working again, so let's keep going. Sorry about that. Okay, so cookies is what we're talking about, and we're looking for the relationship between cookies and muffins. So cookies is 12 more than muffins. So cookies is the same as muffins plus 12 more. That throws kids off. They want to say cookies plus 12. And we want to make sure we're understanding that relationship so that we can pick the right answer, so that we can make sense when we start doing multi-step problems in upper grades. We're laying that foundation for them here. So then we want kids to check every relationship. We can't just look at the first one in a table and not look at the rest of them. So the two here that are going to get us are B and D, because that tells me if I understand what I'm adding 12 to. I can see here that this is 6 plus 6 is 12, 18 plus 6 is 24, 30 plus 6. So this rule doesn't fit. I can see here 1 plus 11 is 12. This is multiplying, right? And then this throws the whole thing off. So we don't have to worry about that. But these two are going to throw kids off. So we have to work through starting by writing out what is the relationship. Cookies is always 12 more than muffins. So muffins plus 12 more tells me how many cookies I have. So muffins, 12, plus 12 more equals cookies. Muffins plus 12 more equals cookies. Muffins plus 12 more equals cookies. And muffins of 48 muffins plus 12 more is 60 cookies. So we want to make sure. We can also look at this and say, cookies is more than muffins. In this case, is cookies more than muffins? No, cookies is not more than muffins in this table. So even if I don't know what to do with the 12, I can say cookies is always more than muffins. Can I look and see in which tables is cookies always more than the number of muffins? And that would help me figure out how to make sense of what's happening when I write the relationship out. And then the next one I want to look at, I showed you a second ago, has to do with the batteries for toy airplanes. And it gives us the relationship verbal here. It gives us these verbal descriptors. So let's start with what's going on in the problem. We know it's the relationship between airplanes and the number of batteries needed for the airplanes. And we're asked to find which statement is true. So we have to teach kids to start here and say, what relationship could this be? And somebody's going to say it's 5 times 3 is 15. That's great. What other relationship could it be? Well, it could be 5 plus 10 is 15. Okay, those are my options. I could be number of airplanes times 3 is batteries, or it could be number of airplanes, if I'm only looking at the first one, plus 10 is batteries. So we start with the first one and we try to figure out the relationship, then we test it. So if I go to the second one, does my rule fit? Number of airplanes, 7 times 3 equals number of batteries, 21. That works. Does this relationship work? Number of airplanes plus 10. 10 plus 7 is 17, not 21. So now I know it's not an addition. I can continue to check my rule. Is 9 times 3 27? Yes. Is 11 times 3 33? Yes. And I check all of the table. Every time we have to teach kids, we check the whole table. Then I can go down and see what answer choice makes sense for what I've said the rule is. And we can find that the number of batteries is equal to toy airplanes times 3. And we can see that it's right there. We want them to test out the rule, figure out what the rule is, then test it out for the whole table. Okay, please let me know if you have questions on this unit and the standards in it.